Okay, so now we have our nice image that we're going to manipulate. But you can see that this is quite problematic because we have, well, basically, I'm going to explain it this way. We're going to work with 3D. So that means that we need a way to store these values not as 3 floats, like one by one. So we need to be able to define vectors, basically. So 3-dimensional vectors. That means we need 3 values. So 3 floating point values in each vector. And we're going to implement that on our own, which is fun. So we're going to go here and we're going to make a new Kotlin file that I'm going to call, let's call it class. It could be data class, but because I'm kind of scared of it, I'm just going to say class for now. So this is going to be called float3 .kt. So this is indeed our float3, and float3 means we have 3 floats, right? We could call it vec3. Some people call it whatever. There's a million names. We're gonna call it float3 because it's nice. So, well, for those that do have some familiarity with programming, this is a class, so it needs a constructor. And usually the constructor actually is in here. So this is going to be var. So the parameters are going to be very simple. It's going to be 3 floats. So those floats are going to be called x, they're going to be called y, and they're going to be called z. So that is very, very simple. All of these they're just floats. Here we say z. That's also float. Nice. Okay. Let's make another constructor. We can have a secondary constructor as well. So if we want to have a nice float that we don't want to, well, we want it to be all zeros or ones. That's going to be easier to have this way. So we're going to say x float, and then this is going to be this x point x point x. So basically, if I pass 0 to it, that x0 is going to go to all of these positions, x, y, and z, which is nice and helpful. So this is done for the constructors. The thing that we do need to define though here is we're not going to just take these and use it to store floats. We're going to have a lot of operations that are going to be 3D vector operations. So we need to define these because they don't exist, right? So we're going to say operators here. And this is where we're going to put all of our operators. So we're going to start with the way you define operators. So what are operators? They're just like basically ways of operation. The plus sign is an operator. So it just adds things together. The minus sign removes things. So it just basically subtracts. So this is the type of thing that we're defining. And believe it or not, it's going to be plus and minuses. So here we say Kotlin operator. Fun. And we're going to start with a unary plus. So we say unary plus, and then we say float3 because that's what it returns. And then in here, the function, so it returns very simply. Actually, we're doing the plus. I don't know why I said plus. So we just need a minus. All that means is we have basically, let's say that you have a float3 that's called a vector, so a. Minus a needs to mean something. In order to do that, we need something called a unary minus, so define it. So that's going to return. So whenever we have minus any float3, we're going to return a float3 that is going to be literally minus x, minus y, minus c. So just let's just inverse, not inverses, but it inverts all of these values. Okay, that's the first operator. The second operator is going to be the plus sign. So we do need to define what a plus is. So we're going to say float3 dot plus sign, because that's what it's called. And it's going to be v float3. So what does this mean, basically? So this means that when I have a plus v, this is going to be a. So that's the first float3, and this in the parentheses is going to be the second. It's going to be v. So in here we're defining exactly what's going on with this. So quite obviously, we're just saying x is plus equals, so the current, let's say float3, is going to be v dot x, y is going to be plus equals, so we just add the values of the other one. And that's it. Obviously the next one is, we don't need to assign that to define the minus, by the way. So we're moving immediately to the times. So we're saying times assign. Also here we need to say float3. Again, we're going to say v float3. And so now we're defining what a multiplication will do, and obviously the multiplication will do the same thing, but now it's a multiplication sign, so it's multiply equals. And then we have to define, believe it or not, division. So, because we're going to need that. So float3, same thing, but now it is slightly different. So we just say divide. Okay. That's nice. Now, a few other things. We do need to define what, basically, if we have just in case, we do need to define what the pluses are actually going to be in other cases. So that means that I need to define. So I'm not sure whether these are needed, but we're going to do them anyway. So this is plus. And we're going to call this B. Uh-oh. And it returns a float3. And it returns x plus b dot x. So basically we create a float3 that does that. That is returned with these values, y plus b dot y and z plus b dot z. Okay, and we're going to define the other ones as well. So we're going to have this many. So we're going to start with minus, and this is going to return to minus. And here, this is our times. And it's going to be the same, but it's going to be times. And now this one is, so we have to do a few here. You see, well, we have a times. We're going to have another times, believe it or not, because sometimes we want to multiply a vector by a scalar value. So that's also going to be b. But this time it's going to be just a float, not a float3. But that's always going to return a float3. So obviously the scalar is just simply going to be multiplied by every single element here. That's it. Oh, it's not multiplied. Oops. So now it's going to be multiplied. Cool. Then the other thing we're going to have, because apparently it is needed, because Kotlin is weird, is we also need to define the float dot times. The reason is we're going to have times where we're going to have a scalar times. So it's basically this one, the first one, this is defines, if I say vector 3, you know, a vector, let's say a float 3 times b, which is a float. But this one defines b, which is a float, times a vector, so a float 3. So we do have to define this as well. So in this case, I'm going to say b float 3 because why not? And again, this is very similar. How we can do here though is we can just say, if you're smart, I mean, you could just write it again, but you can say, well, I've defined what the actual float 3 is. If I say b here times this, then this should work. Or not. It doesn't like something here. Oh, it's because this one exists. I bet you that's what it is. Yep. So yeah, obviously this works. Operator. So finally we need the division. So let's just use the one underneath. So we're gonna say div, and now this is not gonna be obviously vector vector. It's gonna be div with a float. So we're just gonna have a float. This is gonna be float 3, and we're just simply gonna say, just to be a bit smart, we're gonna say return. And we're like, okay, I've defined what 1 over b is, because I know what that is, right? So what I'm doing is I'm inverting this, and then I'm saying times, because I've defined that, this. So yeah, just to do this a bit quickly. The other thing we want to define is something called, these are very mathematical, but we also want to be able to access these values. So we want to say fun, I'm going to say get, and this is going to be I int, and it returns a float. So this is the way we get all of these values x, y, and z. Obviously we can say dot x like here, or dot y dot z, but sometimes we'll want to do this a bit easier by saying 0, 1, 2. So like it's an array, right? So we can say, I want to say 0, so that's x, 1, that's y, and z, that's, and 2, that's z. So the way I'm doing this is by overloading this operator called get. So I'm just very simply going to say return when. This is a very interesting way to do this. So you say when I, and it's a case almost, and you say 0, you have this arrow, and then that returns x, 1 returns y, 2 returns z, and that's the probably fastest way to do it. Else, let's say that there's an error, because obviously we don't have any other values. So I'm going to say invalid access request. That's it for the operators. However, there are some nice other things that we want these to be able to do, right? Because we have a float 3, we have a vector. Let's call them vectors from now on. We're gonna call them float 3s as well, but we need to remember that they are vectors. So the first thing that we need is, well, let's say here related functions or something. So the first thing that we need is we need to be able to, what does it not like here? Oh, that doesn't matter. So what we want to be able to do first is we want to be able to get the length. So a vector has a length, right? It has a magnitude, it has a direction, which is like, it's going to be the length. We're going to start with the squared length because we're going to use this as well. So we're going to start with a squared length. What is a squared length? Well, it's just the length without the square root. So that's the fastest operation. So we're going to start with this one. And we're going to call it squared length, believe it or not. And it obviously returns a float. And it's done the way you expect it to be done. So it's literally x times x plus y times y plus z times z. And we're going to use that function to get the length, which we're also going to use. So it's just the normal length. And in this case, it's just literally going to be square root of the squared length. Okay. Cool. Oh, that was weird. Okay, so we have the main stuff here. It doesn't like that I'm naming them like this, but actually doesn't like that it's not private. Who cares? So those are the first two operations that we get. There is another type of operation that we can get, that we like to get. So we want to have some randomness that we may use, and we're going to use. So we're going to have a randomized function. So basically it's going to be randomize. So this is just it. And the way this is going to be done is basically we're going to randomize the values of x, y, and z. So it's going to be math dot. There is a math.random, by the way, so that we can actually use that. And we're going to convert it to float. And we're going to do this for, for y. And we're going to do this for z, which is nice. And we're going to have one more function that is also going to be called randomize. So we're going to have another overload of it. That's going to take min and max values just for the purposes of controlling this a little bit better if we want to. So this will actually do the same thing, but a bit better. So this is going to be, well, we're going to create another function for this. So it's going to be called random float range, and basically it's going to have min, point, max, and that's going to be the same for all of these, y and z. Okay. Obviously, we need to create the function. That's what we're going to do now. So we're going to go to our utilities here. We have one already. I'm going to go above it because this one is going to stay underneath. And I'm going to call it random float range, as expected. And here it's going to be min, which is going to be a float, and max, which is also going to be a float. So this is going to clamp basically random. And very simply, this is going to be min plus max minus min. And then we just take our random float. That's it. Also, this should return a float. So this should allow us to get the values that we want. Sometimes we will not have that. And in a bit, we're going to actually test this. Now, there is more, and we might as well finish with it for this part. Actually, I think we may or may not need the one. I'm going to add one more function that I'm going to call inside backside check. What this function does is it checks, like if I hit, let's say, something that has a normal, like a triangle, I can tell whether I've hit it the way I want it to, like along the normal, like where the normal is pointing or not. And that's going to be helpful. So just in case, I'm going to actually put this here. So n is going to be our normal. Ray direction here, that's what ray D means, is going to be the direction of the ray. So we're going to see whether a ray actually, where the ray is pointing compared to a normal. And what this is going to be doing is going to be, well, first of all, we're going to say new n equals n. Oops. This won't really matter much. Just basically copy it. I'm not sure if we're going to use it, but we're very likely going to. And one thing you'll see here is we have a dot product, which we also have to implement. And believe it or not, yes, we're doing vectors. We're going to have dot products and we're going to have cross products. So the math of this is pretty simple. I'm not going to explain it. I'm going to explain it when we use it, actually. And return the new one. So what this will do is basically invert the normal if we hit it the other way, and that will be helpful. And the way we know that is with the dot product. Now, the dot product needs to be implemented. For, I would say, yeah, I would say let's not put this here. Let's put it, sorry, in the utils, because that's a better place for it. So let's put it here. And obviously, yes, there's this thing. It's a dot product. So here, I'm going to go back to our flow 3 because there's more to do. The next thing to do will be to normalize. What is normalize? Well, we have a length on a vector, and we have a magnitude, and we have direction. In order to get the direction on its own, which we're going to do a lot, we need to normalize it. So that means we get rid of the direction of the magnitude, kind of. We said the magnitude is 1, so basically the magnitude doesn't matter anymore. So basically we just have the direction. And an array, like a array we cast for ray tracing, is going to have a normalized direction always. And the magnitude is going to be stored, so the length of the array is going to be stored separately. So yeah. So here, we're going to say first fun, because it's a lot of fun, normalize. And it's going to be val. So obviously we need the term. So this is going to the length. So it's going to be the inverted length. So we have our length function. And then basically we just take all of these values and multiply them with this length. So I can probably just do, yeah, I can probably just do this times inverted length. We're going to test that. Okay. Oh, this is not going to change them though. Yeah. So basically, yeah. Okay. Sure, let's keep it like this for now. The next step is to have the dot product that we just discussed. So we're going to have a second vector, and it's going to return a float because that's what a dot product returns. It takes 2 float 3s in this case and returns a float. So it's a dot product. So literally what you expect it to be. So nothing weird here. Just a normal dot product. This should be fine. Then the second part, well, there's a dot product. We said there's also going to be a cross product. So we need that as well. Don't worry, we're not going to touch these again. And so for this, it's a slight different thing. So it's going to be, this returns a float 3. And so we're going to say return float 3. And basically just what you expect. So we have B, we have Y times B times B, or the Z of B minus Z times B Y. Hoping I'm not making a mistake here. and then z times b dot x minus x times b z, and then the z value is going to be x times b dot y minus y times b dot x. So this is just a cross product. Perfect. So we have our cross product working now, hopefully. And there's a few more things that for now we're not actually going to be implementing. So I'm just going to write to do more. But for now, we don't need it. So, I mean, we have all of these things done. So let's test it. And one way to test it is to just literally use the randomize. So we can actually take that. So what I was talking about is we did the utils here, but this kind of sucks. So we're going to make another one. Same as it is. But now we have a float 3. And with float 3s, we can have vectors, but we can also have colors because that's 3 floats. So it's going to be a float 3. We're going to call C because it's a color. Jesus. And here we're going to have C.x, C.y, C.z. Okay. That's really nice. And we don't actually need this. I don't want to get rid of it because we're never going to use it. I'm going to comment it out. Classic programmer. And perfect. Now, we're going to go to our main activity. And obviously this doesn't work anymore. But what we can do is we're going to say that the color now is a random float 3. So we can grab this, probably like this, and have val, let's say rand col equals float 3 0.0f. So we create float 3, and then, so obviously that's going to go here. Perfect. So let's see if we, for now, if everything works and we get a black one. And then what we're going to do is we're going to actually randomize it, and we're going to get a random one in every pixel. Okay. So now we're going to say rand col dot randomize. And now I'm going to run it. Now we should get a random image here. Hopefully. Yes. And that's pretty uniform too. So basically our functions work. Hopefully we're going to find out when we do some more operations, but that's it for now. After this, we're going to implement a few more things because we also need a float 2. That's going to be very easy to do because it's basically float 3, but simpler. And then we're going to go into our arrays and see what our arrays look like. And believe it or not, our arrays are going to be the simplest part because it's just literally going to be, I mean, you need 2 things for array, or 3. And we're going to explain what these are in the next one.